Let me ask you a question. Have you guys ever jumped from a ramp in a shopping cart? Hmm, I'm pretty sure you all have. Let's take a look at this, please.
With the addition of shopping carts in Fortnite, there have been some incredible stunts that people have been able to pull off.
Look at
That's
that
to be
height.
expected when you give us the ability to ramp off of
Look
range
at that jump.
structures from Sky Limit in a grocery trolley. Oh, and
Amazing.
did I mention with the ability to shoot while you're in the cart?
I like that, and I'm sure you're all familiar with it. It's a very popular game online. Everybody's playing it nowadays. All right, so this is gonna be good for the lesson. So let's proceed. I'm gonna stop the video right here. Hi everyone, this is Mr. Jim Martinez. This is your 8th grade science channel. Today we're going to be talking about potential and kinetic energy. Well, actually, we're going to focus only on potential energy. So let's get started. On potential energy, there's a couple things that we must remember, right? There are 4 different types of potential energy. We're going to be looking at all of them, right? Just a quick review. Well, the gravitational potential energy, elastic, chemical, and nuclear potential energy. So let's take a look at all of them, one at a time. All right, let's start with gravitational potential energy. All right, so we can see over here, and this one is the roller coaster. We have gravity pushing on the carts down the slope, and on this side we have this side over here. We have this a rock almost falling from the ledge of this mountain. All right, both of them include gravity, right? Because gravity has to push these objects down. All right, we also have elastic potential energy, and that one has to do with this coil that you can see right here. We can see the coil right here. We can see a rubber band over here, and we can see also a bow and arrow, well, a bow that is being stretched. Both or all of them have elastic potential energy. All right, over here we have chemical potential energy. Now, chemical energy includes, of course, food, right? Food will give you, well, it's energy, it's potential energy, and that's what it's considered of. A battery is also chemical energy because all the chemical bonds that we have inside can pretty much store a lot of energy. Okay, keep in mind that potential energy is stored energy. Now here, the last one is nuclear energy. All right, nuclear is also considered a potential or nuclear potential energy. So there you go, we have all 4: gravitational, elastic, chemical, and nuclear. All right, there's a couple things that we are going to be focusing today. Today we're going to be looking at percentages. Now we're going to be looking at numbers, all right? And numbers are important when it comes to STAR, our test you're going to be taking in 8th grade. So let's take a look at this and let's see what we can do about it. First of all, let's talk about percentages, right? Keep in mind that as we were looking today in the classroom, the highest elevation in an area like this one over here is 100% energy, right? And the lowest elevation in this case, let's say the track goes all the way over here, this will be the lowest elevation area, and this is 0%. We know that pretty much half of the ramp, somewhere in the half area is going to be 50%, and somewhere over here will be 75%. This area will be 25%. As you can see, that potential energy as you go down the ramp decreases, right? There you go. Now, we're going to be looking also at how this can influence a different type of ramp, right? So let's take a look at this. Now, if we had a different ramp, this, and then it has another hill, right? Just like what we talk over here in the classroom. We cover all this in the classroom, so just in case you forgot about it, you're gonna be able to do this. So there's the cart. This area is the highest elevation right here, which is your 100%. This is your, I'm sorry, your lowest elevation is 0%. And of course, somewhere in between is your 50, 75, 25. So as you can see, potential energy as you go down the ramp it decreases, right? Now, what will happen if, like for example, in this ramp, right, you start going up, right? As you go up, potential energy is gonna increase. So from here, in this hill, in this particular hill only, right, this area will be 100%. This is the lowest elevation, which is 0%. And from there, you can always get half and get the 50%, 75, 25%. So as you can see, as you go up on the hill, the potential energy increases, right? So keep that in mind. That's going to be very important. You need to know that for the test. All right, let's move on to another one. Let's take a look at this pendulum, right? It's called pendulum, okay? Or a swing. We can have a swing. It will be the same thing, right? This swing or pendulum, it's going to experience something similar, right? Let's say that we have this swing all the way over here, right? So if we drop it from this height, this will be your 100%, right? And everything below, like this is the lowest area. This is the highest area because we're dropping it from here. So this will be your lowest area, which is your 0%. This area right here, 0%. Somewhere in between, if this is in between, will be 50%. Somewhere over here will be 25. I'm sorry. This is 75. And over here will be somewhere 25%. So that's what happens as potential energy decreases as you go down to the lowest elevation, right? And then once again, it started swinging up. And as it swings up, let's say it swings all the way over here, right? Well, now over here will be 100% potential energy. And somewhere over here will be like half of it, 50%, and so forth and so on. This will be 25, and somewhere over here will be 75. So as it goes up, it increases the potential energy, and as it goes down, it decreases the potential energy. So keep that in mind also. Right, we're going to move on to the next one. The next one has to do more with elastic potential energy, right? We can see this is a spring. This spring in this section is just relaxed, it's at rest, right? So if it's at rest, that means that we're not pushing it, we're not pulling it. This is 0% potential energy because it's at rest, right? But if you push it down as far as it can possibly go, you push it against the wall, then let's say you have your hand right here, right? Pushing it down. This is as far as it goes. Then you will have 100% potential energy, right? If you go like halfway in between those two, then here will be your 50%, and so forth and so on, right? The more you press, the more percentage it will increase on potential energy. All right, this is a bow and arrow. Let's take a look at it. Right. Now this one is at rest. The potential energy on this one on the left side is 0% because it's not putting any pressure on it, right? Let's say that this one over here on this side is the max you can possibly pull this thing, right? So if it's the maximum you can pull it, this will be 100%. And anything, if this is 0 right here, then this is 0 right here, right? This is 100%. Then somewhere over here will be 50 and so forth. I think that's all. That is all for potential energy. All right. I hope this is helping for your homework. Remember, you had homework today. You're supposed to be doing page number, what is it, 12 and 13. Remember to do page 12 and 13 in your composition book. Right? Have it ready by tomorrow. We'll see you later. Bye bye.